If you can, please download or print out the PDF file on the description below so you can work with me. An Eulerian circuit is a walk that passes through every edge once and starts and ends at the same vertex. It is the same as Eulerian trails, except for the Eulerian trails, they start and end at a different vertex. Let's have a look at this network here. Let's say I start at C and travel to E, and from E I go to B, from B to D, and from D to I, from I to C. So I start at C and I end at C. So which is an Eulerian circuit. Or I can start at I. Let's start here. So I start from I to C, from C to E, from E to B, from B to D, and from D you go back to I. So it ends here. So I start and end at I. So this is an Eulerian circuit because I start at I end at I, and I travel through every edge once only. So this is an Eulerian circuit. Please take note on this. For an Eulerian circuit to exist, all the degrees of vertices must be even. So let's look at this network here. At vertex I have a degree of 2. For vertex B, a degree of 2. For vertex C is a degree of 2. For vertex D, a degree of 2. And for E, a degree of 2 as well. So it satisfies all the rules. Okay, let's try this example. Identify an Eulerian circuit for the network below. Before we even try to find Eulerian circuit, we need to find out whether it exists or not. In order to do that, we need to find the degree of each vertex. Let's start from I. On vertex I, we have 1, 2, so the degree of 2. And vertex B, we have 1, 2, 3, 4, so the degrees of 4. And for C, we have 1, 2, so the degrees of 2. For D, 1, 2, so the degree of 2. And for E, we have 1, 2, 3, 4, so the degrees of 4. And for F, we have 1, 2, so the degrees of 2. So for an Eulerian circuit, all the degrees of the vertices must be even. So from this network, all the vertices have a degree of even. So therefore, we can identify an Eulerian circuit for this network here. So for an Eulerian circuit, the walk must pass through every edge and start and end at the same vertex. Of course, there are many answers for this. So let me start on C. So let's start here. So and I travel from C to D, and from D I travel to E, and from E I travel to F, from F I travel to B, from B I travel to E, and from E I travel to I, from I travel to B, and from B I travel back to C. So I start and I end at C, and I visit every edge once only. So this is an Eulerian circuit. Alternately, I can start from I. Let me start here so I don't forget. I start from I and travel to B, and from B to E, from E to F, from F travel to B, and from B travel to C, from C to D, from D to E, and finally from E we go back to I, and it's end at I. So noting that I travel from I and end at I as well, and I visit every edge once only. So this is an Eulerian circuit. please stop the video. Try this one yourself. Before we even start identifying Eulerian circuit for this network, we first need to identify whether it even exists or not. So first of all, we need to find the degree of each vertex first. So for I, we have 1, 2, 3, 4. So we have a degree of 4. For B, 1, 2. So we have a degree of 2. And for C, 1, 2, 3, 4. So the degrees is equal to 4. And for D, 1, 2. So the degrees is equal to 2. For E, 1, 2, 3, 4. So the degrees is equal to 4. And for F, 1, 2. So the degree is equal to 2. So we have 4, 2, 4, 2, 4, 2. So they're all even degrees. So therefore, we can identify an Eulerian circuit in this network. Now, of course, there are multiple answers for this question here. So your answer could be different from mine. So make sure your answer met all the conditions, okay? Let's start from C here. And then we start from C, we travel to D, from D to E, and E to C, and C to I. And from I, we can go to F, from F to E, from E to I, and from I to B. Finally, from B, you travel back to C. So I end here as well. So I start and I end at C, and I visit every edge only once. So this is an Eulerian circuit. Or you can start at F. And then from F, we travel to I, from I to B, and from B to C, from C to D, from D to E, from E to C, from C to I, from I to E, and finally from E, we come back to F. So it's end. So with this one here, I start and I end at F, and I visit every edge only once. So this is an Eulerian circuit. So noting that the circuit is F to I to B, B to C, C to D, D to E, and E to C, C to I to E, and E to F. We're back to the beginning. Thank you so much for watching my videos.